I've seen plenty of people who've just pencil whipped their ISO certification. So we go and we look to see what's actually happening on the factory floor, and I'll go into the factory, I'll walk around the factory, I'll look to see whether they are really trying to standardize their operations, whether the operators in the factory have been well trained. I'll do things like pick up whatever piece parts that are there and look at, if it's a welding shop, I'll look at the quality of the welding there. It's very easy to see whether the quality of the welding is there.
Welcome to Manufacturing Insiders. Today I have David Crawley with me. He's a PhD. He got it from Cambridge. He's got a great British accent. He also went to Oxford for his undergrad. Just a very illustrious educational background in semiconductors, robotics. He's an inventor, a CEO, and he's really shaken up the industry. He's also an expert on cost cutting, which is a big topic in manufacturing today. So I'm really excited to pick your brain, David. Welcome.
Thank you so much. Thanks for having me.
So I'm sure I didn't do your background the justice it deserves. So can you give us a little bit more background on yourself?
Well, I did do a PhD in semiconductor physics, postdoc in semiconductor physics, astrophysics. Then I went and worked for McKinsey for several years, and I worked in the high-tech industry, helping lots of companies improve their performance, and did a lot of factory lean-outs. And then I worked for one of my clients, and I worked in doing product development improvements. We cut product development lead time at one of my clients from 326 weeks down to 17 weeks by applying the same sort of methods that we applied in factories to product development. There's just a lot more opportunity there.
What kind of product was that?
That was a semiconductor device or a type of semiconductor device. Just there's a lot of opportunity in improving product development with Lean. After that, I was looking for a new challenge, so I started a robot company, and that's what I've been doing ever since. So I run Ubiquity Robotics. We build platform robots that help people. That help other robot builders build their robot their products, and we design custom robots as well, of course.
Okay, so your main platform kind of addresses I've talked to a lot of robotics guys, that are doing kind of warehouse sort of robotics and organizational things, even some that are doing like mobile charging robots for electric vehicles. So the idea here is, instead of all of them kind of recreating the wheel for the transportation side of things and the navigation side of things, you're creating that single platform that they can apply to whatever their specific use case is.
That's absolutely right. I mean, if you look at most of these applications, they all need the same core things. They all need mobility, they all need navigation, they all need power, they all need compute. And so we provide a base platform that provides all of those. And that base platform is a springboard for you to use to design your own application, be it a conveyance robot in factories or a robot that gets used for measuring applications, or a robot that gets used for drink serving. So I'm very fortunate that I have a variety of conversations with people all of whom are trying to build mobile, ground-based mobile robot applications, and we try to help them do that. We always use our platform as the starting point. And with that platform, you can really accelerate your product development. You can do it for a lot less money than you otherwise would have to do it. And that enables you to move a lot faster.
Okay. Yeah, I mean, I think that there's no point in recreating that wheel when somebody like yourself has created the software and hardware, right?
Mm-hmm. That's right. Both the software. About 50% of our team is software. About 50% of our team is hardware.
So how do you make the jump, and why do you make the jump from semiconductors to, I mean, obviously there's crossover. You need the chips inside the robots, but, how do you make that jump?
Well, when I was doing, research, essentially I was building electrical systems, mechanical systems, and software systems. And I was using these systems to analyze semiconductor devices, but I was an experimentalist. I was actually building experiments, so it seemed very natural to me when I started building robots. It seemed very familiar.
Right.
Fundamentally, doing sort of management consultancy type things was fun, and I learned a lot. But I'm a technical guy at heart, and I love building things. And I am not a happy individual if I'm not building something. So it happened to be robots, and it kind of took over my life.
Yeah.
So yeah.
Well, I mean, it's obviously a great industry to be in, and it's the way of the future. As we have kind of an aging workforce and a
Mm-hmm.
workforce situation that's not going to get any better,
Mm-hmm.
um, robotics are our best option.
Right.
Um,
And we're looking at clients who are just struggling to fill the sort of roles that robots will have. I was talking to a large national postal carrier today, and they have an establishment. They need about that they're short about 10% of their workforce because they just can't find people to fill those roles.
right.
And the same is true of all my warehouse customers. 94% of warehouse customers surveyed say they are struggling to hire the people that they need to fill the roles that they've got available for people. In logistics and warehouse, the case is very easy because since the rise of e-commerce, there's been a huge increase in the need for those kinds of services because more and more people are having things delivered to them, and more people need those sorts of delivery services. So this is the way of the world, and we need to find ways in which we can supplement and help the workforce with automation so that we can get the job done.
Yep. How is we're seeing pretty fast progression in AI from a consumer perspective.
Mm-hmm.
We all have access now to Perplexity and ChatGPT and Grok and all these LLMs. Um, from a bit of an outsider's perspective, it doesn't appear to me that robotics hardware has seen the same level of improvement over the same period of time. Do you agree or disagree with that?
Yeah, I mean, I think you have these sort of watershed moments in AI, and it seems so enticing. The development of the perceptron, and many decades ago, the first neural net, effectively, led to a huge interest in AI that was followed by an AI winter. After that, again, there were further developments in the field that led to a resurgence in interest. And again, after that, there was an AI winter again. What we're seeing now is that the advent of transformer architectures and and effective working large language models have led to this, again, surge in interest. And, they're getting applied in lots of ways. And, we hope that this can continue, and the growth of interest can continue. But again, you may see a pullback in terms of people's interest in the levels of investment that go into that area.
Mm-hmm.
In terms of robotics hardware, hardware is, of course, developing, and it's develops at its own rate. That's a little bit different to software, and you haven't had the same kind of massive watershed breakthroughs. But if you look at it from, say, a cost point of view, from a performance point of view, you haven't seen the same kind of watershed improvements. But if you look at it from a cost point of view, you absolutely have. I mean, we are now producing ROS robots for 1/100th of the cost of ROS robots a decade ago. So there have been huge changes in the cost position. There have been huge changes in the number of robots that have been deployed. You have stories like Amazon having deployed 1 million robots now, right?
Wow.
So there has been a huge shift in the number of robots deployed and the cost of the robots that are out there. And those sorts of things have occurred. Are those shifts as big as from 0 to to 1 million users by ChatGPT. Well, maybe not, but still, I think that the shifts are pretty significant and lots of exciting things are happening.
Okay. And I guess what I was kind of thinking along the lines of is allowing for robotics to have some sort of an interpretive function.
Mm-hmm.
Because to me, what I see in robotics, you program it to do exactly XYZ task. To move this from point A to point B, or to pick and place this part,
Mm-hmm.
whatever it might be. But uh, for it to really explode the usage of robotics in manufacturing facilities, especially in those high mix situations or those low volume situations, you almost
Mm-hmm.
need some sort of ability for that robot to also learn and understand what's being instructed to it, and without having to go through and physically program it,
Yeah.
where
Yeah.
you're getting some of that interpretive effect from those language models.
Yeah. So you need those interpretive effects. Plus, I think for manufacturing in particular, you need significant advances in perception. So, perception, the ability for the robot to take in an image and then tell what's in that image.
Right.
I always use the example of, can it tell the difference between a cat and a dog? Humans are really good at that kind of task, those sort of perception tasks. If you think about the tens of thousands of objects we look at every day, we rarely make a mistake. Robots and AIs, while spectacular in many cases, they're still maybe 2 orders of magnitude away from what a human can do. Mm-hmm. And so robots will make mistakes in perception at significantly higher rates than humans. And if you're in a manufacturing environment where you need to reduce your quality defects down to 6 Sigma levels, that's just not going to be acceptable. And robots still need to do quite a lot on the perception side of things to get good enough to be be suitable for application in certain manufacturing tasks, to be able to do general purpose manufacturing tasks.
Right.
More work needs to happen on applying LLMs to robotics, so that you can then instruct a robot in natural language to tell it what to do. So
right.
There are some gaps, but those are all areas that are being worked on. And I would not be surprised if in 5 to 10 years' time we are talking about being able to talk to robots in such a way that they can do tasks for high mix, low volume areas.
Right.
We're not there yet. There's work that needs to be done. It could take a few years before we get there, but a lot of people are working on it right now. We have programs where we're looking at those perception problems, and we feel very optimistic about those programs. So I think you're right. At this time, robotics is more suitable for manufacturing environments where the volumes are a little bit higher. But in the future, I think that that's not going to be the case.
Gotcha. Okay. So in terms of your experience in building custom robots, what has been your most exciting, when you tell a story about a problem you solved, what story is that?
I talk about lots of different robots. One of my favorite robot projects was actually not even a particularly high volume product. It was a drink serving robot that we designed, and we designed it with a fashion designer. So we had this beautiful Art Deco exterior to the robot, and all that the robot did was it looked around the room, used person identification to find people in the room, and it would drive up to them and it would serve them a drink. And it's a fun, easy to understand product. It's something that people can grasp, and people like the idea of a robot that's a little bit like that. So I tell that story over and over again because everybody can understand it, and it makes sense to everyone. We've done similar robots that have similar functionalities, or we've looked at robots that have similar functionality. We looked at robots to do people following in palm oil plantations. We've looked at robots to do people following in warehouses. We've had robots that can do very detail-oriented things in lots of other environments. But unless you understand what those environments are, then it's just tough to tell those stories. Whereas everybody knows what a cocktail party's like, right? So
when you say people following, what exactly does that mean?
Well, it's fairly easy to get a robot to identify a person. Just have a camera on the front and pass that camera data into a perception AI, and the robot will detect if there's a person in front of you. And if it can detect that there's a person there, so the robot stands in the center of the room and it turns and it looks around. Mm-hmm. And when it sees a person who's there, it drives towards them until they get bigger in the field of view. And then in some variants, we designed it so that it would offer them a drink. It would say, "Hello, here, would you like something to drink?" The robot would be set up with drinks. And then, a person could take that drink and go on. And it's a bit like a cocktail waiter walking around a cocktail party with a tray of drinks. It's the same sort of concept.
Okay. Yeah, when I asked the question, I was thinking that because you mentioned a couple other applications, and so I thought it was a different terminology other than like literally. It's just
literally, that's what we designed. But the point is that we designed that. I mean, that was a terribly low volume product, right? But the technology that we developed for that can get applied to other things, and can get applied to people following in all of these other areas. So, we think that the ability for the robot to interact with people is sort of fundamental and something that anybody's going to want.
I was going to say, if you're going to have it in those waiter applications, you're going to want it to flirt a little bit.
Yeah, that's right. So, that's right. So that's one of the applications that we put in, but we've done lots of other applications. We've done applications in delivery. We've done applications in sensing. So robots that drive around and, for example, measure the lighting levels in environments, so that the robot can, so that an environment can meet statutory lighting requirements. We've had robots that will drive along tunnels and measure distances in the tunnels to ensure compliance with certain standards, or to make sure that the tunnel has been built right. We've built all of these kinds of. We've of course done warehouse robots that can deliver things in warehouses, and done retrofits for other people's robots as well. So we've done all of these kinds of things as examples of things that we've done in the past.
Yeah. So I talked to a lot of contract manufacturers. You could be talking about anywhere from a machine shop to a fabrication shop, injection molders, PCBA people. Mm-hmm. Everyone's aware that robotics is a growing industry, and they want to position themselves to leverage that and to be part of it. Mm-hmm. How vertically integrated are you with your facility there? Do you work with outside shops to do, machining of parts, to do fabrication, and what do you look for?
Absolutely. So we work extensively with outside manufacturing. So we try to retain the technology elements, so the mechanical design, the electrical design, and the software. But the manufacturing is all outsourced for us. We multi-source the outside manufacturing. Now, for us, what I care about is, does the manufacturer have some type of quality system and an awareness of quality manufacturing practices? So I almost always go and visit the manufacturers in person. And the first thing that I do is go and and walk the line in those manufacturing facilities to see whether when I walk the line, do I see a operations improvement mindset? Do I see the fact that they've got standard work in operation, in effect on the factory floor? Do I see that they have improvement initiatives that are active and operating? Do I see that they are tracking metrics to improve their operational efficiency or not? And those are the sorts of things that I will look for when I'm trying to find a manufacturer. And what I really care about when I go to a manufacturer is, do they have, as far as I can tell, a quality mindset, which will mean that when we produce our robots with them or our components with them, that I am likely to get a quality produced part. I've been to, I don't know, I've lost track of how many factories I've been to. I used to audit factories professionally, of course, when I was with McKinsey. Probably more than 100 factories by now. And I used to help factories improve their productivity. And now what I care about when I go and visit a factory is, do I see that the practices in that factory are likely to lead to high quality outcomes in terms of the manufacturing the manufacturing runs that we do with them.
For sure. So, what about physical capabilities? I mean, I guess when you are putting a robot together, when you're building a robot, you're going to need some fasteners. You're going to need some, turned parts. You're going to need some really intricate, maybe in some 5-axis machining for, parts that have multiple surfaces being machined. What other types of parts, maybe that I wouldn't have thought of, do you need made for a robot?
You'd be surprised at how standardized it is. And we take the view that we should try to design our robots without requiring too much unusual machining. I mean, we do a lot with sheet metal. We do have machine parts as well. But, we sort of take the view that if we want to produce something, that's we take the view that if we want to produce something that reaches our customer at a reasonable cost and timeline, that we should try to avoid doing things that are unusual or unexpected or non-standard. So we typically try to strive for using machining that is or machining methods or metal forming methods that are widely known in the industry and relatively standard. The sort of things that we are interested in are things like hydroforming, because that enables you to produce sheet metal parts with relatively low volume. So if you're building custom robots, then that's an area that's interesting for you. And sometimes our electronics builds wind up having to have relatively high layer counts and buried in blind vias and things like that. So all of the stuff that we try to get is stuff that is at least somewhat available. And we want to avoid a situation where there's only one supplier in the world who can do some particular manufacturing step for us. So
that's interesting. I like that you mentioned, so you said hydroforming?
Yeah, hydroforming. So
I don't know anything about that.
So that's a sheet metal forming technique where you can lay a piece of sheet metal on the press, and typically you have a rubber diaphragm, and you put oil into a cavity beneath the rubber diaphragm, and that pushes the sheet metal out into a mold, and it allows you to, in a single step, produce these very deep drawn parts. So when you're building a robot, you often have deep drawn parts. You want to do them in a single step because that's going to reduce cost.
Right.
And the tooling for hydroforming is typically a lot less expensive because you only have to produce one deep drawn tool, one side of a deep drawn tool, as opposed to say a progressive die where you may need 4 or 5 sets of tools to do something like that. So
I see.
hydroforming is a great choice if you have deep drawn parts and you have relatively low volumes. So it's very, very popular in aerospace, for example, and that's something that we're very interested in as well. So
That's
yeah.
cool. Oh, I'm glad I got to learn about that because I just when I think I've learned every type of manufacturing process.
so yeah.
Well, no, that's great. So what about do you ever find yourself wishing that you had a supplier that had multiple, let's just say, adjacent types of manufacturing? Like, for example, you wish that you had a machine shop that could also do some welding and fabrication and assembly because, it's going to consolidate your supply chain. Like, do you have
Yeah.
some examples of that?
Yeah, the one thing that I could never find was somebody that used to do anodization as sheet metal, and
Mm,
I mean, we had so many because we produced one of our first versions of our robots were anodized, and our customers loved it. I mean, they thought it was great. They thought that the robots looked fantastic.
yeah.
This wonderful. We did a blue anodize on the robot, but we had to stop because none of our manufacturers could. They would always have to send it out to a separate shop to do anodization. It would always introduce a 2-week delay in our supply chain and cause all kinds of
Uh,
bottlenecks and problems. So all of our robots today are powder coat, which is sad for me because I always thought that the anodized
Anodized was
robots looked
awesome.
better, and all
Yeah.
my customers thought the same as well.
Yeah.
But for practical reasons, we had to change. And also, the other advantage of anodization is you can design the part the way that you want. You don't have to take into account that you know quarter millimeter thick
Right.
layer of powder coat that you've got.
Right.
So yeah. But as it is, we powder coat today, which is a shame, I think. But there you
Yeah.
go. Maybe.
No, that's a really good example. And it's something I preach a lot to manufacturers because if you can have a combination of services, it's going to make you a lot more appealing to somebody that needs both of those services than having to once again send it out to a different shop, have that 2-week delay in your supply chain, have the
Right.
shipping costs associated with that. And so examples I use a lot of times that I've got a customer that does injection molding, but they have a very well developed assembly operation.
Yeah.
I've got a machine shop that also has a really well developed mold polishing operation.
Yeah. Yeah.
So those combinations a lot of times, and even the example I used of a machine shop that can also do some of the metal fabrication techniques like cutting, bending,
Right.
welding, that sort of stuff. Those are great combinations of
Yeah.
services that
Yeah.
that really help you grow your business.
I mean, we typically don't even work with shops that don't at least do some assembly because there's always it's always a case that we're taking a set of sheet metal parts and we're assembling them together with other things. So if we don't see good assembly and most importantly good discipline around assembly, do you have people who, when you give them standard work instructions, they follow the standard work instructions, and those sorts of things. And the other combination that could also work that we almost never see that we would love to see is just two manufacturers that have worked out how they are going to serve customers who want sheet metal and anodization. I mean, imagine if instead of, there's no reason why if you had an anodization shop near a sheet metal shop that you couldn't produce anodized parts quickly.
Yeah.
It's just a matter of the two manufacturers coordinating in an effective manner so that you don't have parts coming out from the sheet metal shop and sitting and waiting while the anodization shop, manages their queue to get the work done. So effective joint management could add value to both places.
Right. So
Uh,
I have an anodization shop that I work with that's about 45 minutes away from a sheet metal shop that I work with.
right.
So maybe I'll put something together for you.
Yeah, no, that would be great. I'd love to do that.
Yeah.
So yeah.
Is it a like as far as California to Pennsylvania, like do you specifically look for suppliers that are geographically proximal to you?
Yeah. So what we try to do is we try to find clusters of suppliers that are try to find clusters of suppliers that are in geographic areas that we supply to. So absolutely, and we try to find them within a close range of each other. That's what we typically try to do. So yeah. If it's supplying into North America, we look for a cluster of suppliers in North America. If it's in Europe, a cluster of suppliers in Europe, and so on, right? And then we try to make product as much as we can among that cluster of suppliers and try to develop that cluster of suppliers. Some things have to get shipped. So, for example, we have 2 different LiDARs that we supply on all of our robots, and they're made in one location in the world, and they get shipped worldwide. So yeah, that's sort of the nature of the business.
Okay. Yeah, I've always had this this kind of obsession with linking suppliers to OEMs, people that need them, and I thought that there could be a role for kind of that supply chain assembly. And the place where my business is located and where a lot of my customers are is excellent for it. So I'm in Erie, Pennsylvania, which is historically a big manufacturing town. Right down the street from us, well, half-hour away is Meadville, PA.
Yeah.
And that's where you find companies like Channel Lock and just some really big manufacturers. But you drive down that main manufacturing strip in Meadville, and you got rubber molders, injection molders, machine shops. You've got literally everything in that little area. And I always wonder like how much the world is aware of this really concise supply chain potential that we have in this area.
Yeah, and it's sad because these manufacturers do exist, but how is it that they are getting the visibility? It doesn't seem like there's an online equivalent to that makes it easy to find all the manufacturers that you want, right?
Right.
If I assemble a supply chain in China, it's straightforward. I go to Alibaba, right? But I mean, the equivalent in the US, it just doesn't seem as strong and as well known. And the ability to find and assemble supply chain, supply chains. Just, I mean, obviously there are manufacturers there, but you really would like to see the ability to assemble those supply chains in a way digitally that you can do in other parts of the world.
Right. So how would that work? So interestingly enough, I through a very long story I'm not going to get into, ended up building a website called RFQ USA.
Yeah.
And it's that's kind of the goal of it is, for
Right.
any OEM to go out there and find the right suppliers in the right places with the right qualifications. Now we've just built it and we're just building up the database and all that kind of stuff in it. But from your perspective, how would that work? Would you say, okay, here's the four types of manufacturing I need. I need somebody that can do PCBAs. I need somebody that can do the hydroforming. I need a fabrication shop. I need anodizing. I need 5-axis machining. And so then you want to have a cluster of those
Right.
5 capabilities in one particular area. And then I would assume, does there has to be a go between for these companies and say, hey, listen, you guys are all working together. How do we, I guess, what
So
pieces do you need to make that happen?
So for us, the way that we would do it is that we would try to source, for each type of supplier, we would try to source between 5 to 10, potential alternatives. And we would go and visit them and audit them. And we have an audit process that we use.
Okay.
Um, and as I mentioned already, we would try to audit them primarily on whether they have a quality mindset or not, and whether we think that
Okay.
they are using quality management, whether they have a quality management process and they are managing quality.
So if
Um,
they have an ISO certification, is that the check in the box you're looking for? Or do
you
you see
know,
people that have ISO certification that are not really
you
doing
know,
what they need?
ISO certification is good. It indicates that you're thinking about it at least, and so forth. But and ISO certification is excellent. But at the same time, I've seen plenty of people who've just pencil whipped their ISO certification. So we go and we look to see what's actually happening on the factory floor, and I'll go into the factory, I'll walk around the factory, I'll look to see whether they are really trying to standardize their operations, whether the operators in the factory have been well trained. I'll do things like pick up whatever piece parts that are there and look at, if it's a welding shop, I'll look at the quality of the welding there. It's very easy to see whether the quality of the welding is there. Um,
Hmm.
and so I will go and try to see with my own eyes whether the factory is producing a quality product for my customers. I mean, and ISO's good. It's great that people have it, and generally, people who have an ISO certification typically are better than those who don't. But at the same time, like I said, I've seen people pencil whip their ISO certification, and I've seen great manufacturers who don't have an ISO certification,
Right.
and just have got somebody leading the manufacturer who has been trying their best to understand modern manufacturing techniques, and has a heart for trying to improve quality at the ground level and engaging their workforce to improve quality. And we will look for that sort of thing, and we will look
Mhm.
to see to see whether frontline staff are engaged in improving quality in the factory floor. Do they have quality initiatives that are running on a daily basis? Or is it a factory where you have top down management thinks that they have all the answers, and that frontline workers are just there to do what they say, and frontline workers are merely tools for management to produce parts. If it's the former, where management is trying to engage the front line and trying to get the whole organization to improve quality all the time, every day, then you're
Mhm.
very likely to get good quality. If you have management that believes that all changes and must be led by management alone, and that management makes all the decisions, then you're going to find that they will fall behind those others. So we're going to look for that, and we're going to try to see whether the mindset is there.
Mhm.
And if it's there, then we're likely to want to work with them. If it's not there, then we'll try to find a um, a factory which has a stronger mindset and has stronger quality systems and has a stronger sense for trying to improve workers' management processes and production processes all the time, every day, all day. All
Mhm.
right. Does that make sense?
Yeah, for sure. Just kind of back to my original question. So, from a digital standpoint,
Right.
if you were to have this perfect platform,
Yeah.
would your so it sounds to me like you would like to be able to have 4 or 5 of each of those 5
Yeah.
in a similar area, so that way you can vet and pick the final
Yeah.
the
And then
final.
we would go around and we would audit all of them, and we would try to get to know all of those manufacturers, and we would select one or two from of each type, and that's what we would do.
Yep.
And
Gotcha.
then we would assemble the supply chain, and we would try to get those manufacturers to work with each other in a cooperative way.
Mhm.
And what we would try to do is set up a pace setter. So one of the manufacturers would pace set all the others and would pull upstream to produce the product. So typically it would be our final assembly manufacturer, who's very often our sheet metal manufacturer. And what we
Okay.
would try to get them to do is produce the sheet metal. And if they need other parts, so typically for our robots, you're going to need motors and PCBs, they would request manufacturing of the motors and the PCBs from the motor and PCB supplier. That's typically how we would try to do it.
I see.
All
Okay,
right.
that makes sense. How so with the anodizing and sheet metal conversation, what what sort of volume would, if you were to work with a sheet metal manufacturer that could do the hydroforming, what sort of volume would they be looking at?
You're looking at thousands of units.
Okay,
So
annual.
is what you'd be looking at, right? For something like
Okay,
that. That's about the
gotcha.
appropriate level, right?
Okay.
So
Yeah,
so
well, no, that's attractive to a lot of people. Okay, yeah, and I ask these questions because my assumption is there will be people in the audience that would be interested in
mm,
reaching out if they
mm.
have the capability you're looking for. Um, is there? And one other question I kind of like to wrap up with is you may have already answered this because we did talk some about it, but are there any other needs that you've identified in your company? And this could be anything. You need, better waste management or recycling, or you need, could use some consulting in a certain area, or you'd like to generate more leads from the web, or, whatever it might be. Is there anything that you've kind of been thinking about?
Well, obviously, it's always, I love working with manufacturers in a lot of ways, and we love to supply to manufacturers, of course. So we're always interested in manufacturers that are interested in robotics and thinking about material handling problems in their factories, and want a solution for moving things around their factories that don't involve people pushing carts or
Yeah.
or other people pushing carts. So we're always on the lookout for working with people who have those material handling, material movement problems, because that's kind of core for us.
Yeah.
Um, we're always interested in talking to people who have innovative packaging solutions, because we produce both custom robots and standard robots. And on our standard robots, we are always looking for people who have innovative ideas around packaging. So right now, we're trying to produce a package for our new product, which is a small product that is entirely made of cardboard, and trying to find a way of packaging that with cardboard that's both lower cost, but it avoids any plastics in there.
Yep.
Plastics can create a lot of problems for our customers, because they're disposal problems, but also they tend, plastics, styrofoam tends to break apart as you ship it,
Okay.
and it tends to cover the robot. So we're trying to go with an all cardboard package on our latest robot. So we're always very interested in packaging technologies.
Okay.
We're very interested in new sheet metal forming technologies, because I think that's new sheet metal forming technologies can lead to new robot designs that can make our robots better. And then, of course, always hub motor manufacturing. If we can find a hub motor manufacturers that are interesting for us, it's something that we always interested in doing. Right now, we would love to find a good US source hub motor manufacturer that can provide at a reasonable cost. And that was something that we'd absolutely love to find. So,
Okay.
yeah.
Right. Okay. Well, that's all. Yeah, very interesting. And I'm sure that'll be interesting to somebody out there that has some of those offerings. But hey, real quick before we wrap up, though, I kind of forgot about this. You had in your hand there something that you're
Sure.
developing, and I wonder if you could talk about that for a second.
This is our new robot product. So we have robots of all different shapes and sizes. Our biggest robot is about the size of a small car,
Yeah.
and a medium-sized robot is a typical AGV-sized robot. I mean, there are some examples behind me here. I don't know if you can see those.
Yep. Yep.
There's one on the table there. That's about
Yep.
the size of a typical AGV that's used for material movement problems. And then we've just got the newest thing that we've just developed. This is really for a small robot, which can be used for surveying. It can be used for educational purposes and so forth. And we're excited about all of our products. We're just about to release our 6th generation design, which will have a small, medium, and large. Our medium will have about a 200-pound payload, 220-pound payload. Our
Oh wow.
large will have our large will have a sort of pallet-sized payload, so about 2,000-pound payload, and our and our and our small will have about a 20-pound payload. And so we're just about to release that platform. It's going to enable us to produce a whole range of new robots for everyone, and we're very excited about that. So
Yeah, it is very exciting. Yeah, I mean it's a very dynamic space that you're involved in, and I think it's there's no question if you're innovating in the space and providing some quality products that you're going to grow and it's going to be very successful in the coming years here. So I appreciate the insights that you gave us today, and I even got to learn about some new things, and that's always fun. But thanks a lot for coming on, David.
all right, thanks so much, Nate. I really appreciate it. It's a great podcast that you run here.